This is one of our Power Application Controller evaluation modules. The module housed in the 6x6mm QFN device measures 4 inches by 2.5 inches. But that little chip has all of the goodies to drive your 3-phase BLDC or PMSM motor. That is, a microcontroller to run your favorite algorithm and provide motor drive intelligence, a pre-drive power stage to drive your 6N channel MOSFETs, powerful and versatile PWM generation to control your motor speed, 3 differential amplifiers to sense up to 3 motor currents, standalone overcurrent protection block to ensure system reliability, 3-phase comparators to extract back EMF information, quite priceless in sensorless algorithms, analog inputs to extract system temperature, bus voltage, or any other analog feature your application may need to capture, multiple serial ports for different serial communication protocols, and all of the DC to DC switcher converters and low voltage dropout linear regulators you will need to power up your system. Wow, that's a lot of stuff right there, and a good thing, as for the vast majority of cases you will need most of these blocks to drive your 3-phase motor. Like this, like this, or like this. But what if I have a rather small motor? Would it be possible to take those gigantor FETs and somehow squeeze them inside of the PAC device as well? Well, search no more, as I am happy to tell you the PAC5285 device gives us exactly what we've been looking for. Notice the small footprint these reference designs have. They're tiny. Now, I do not have a lot of low current 3-phase motors, so wanted to see what other loads of fun I could have with this small yet incredibly intelligent motor driver/controller. Went to Amazon and got me a couple of these feminine product phase brushes. I knew they would have a brush DC motor and zero intelligence, as there is so much you can sell for $20. Needless to say, this is a brush DC motor with 2 buttons, one for powering up the unit, and a second button to select from 2 speeds. Probably more than enough for your ordinary face washing endeavors, but what if we want some fancier action? A little dremeling got me inside of the unit and sure enough found a brush DC motor, a very small PCB with 2 switches and a diode. Designed a small PCB with the PAC5285 and got busy coding motion profiles. These are 2 examples I came up with just a few minutes worth of coding. In the first, we can see the brush speed slowly accelerating and decelerating from 2 target speeds. On the second, the brush moves back and forth at a fixed rate. Needless to say, these parameters are easy to change and you can obtain pretty much any response you can dream of, thanks to the microcontroller. Try doing that with 2 buttons. Some other goodies I picked up from Amazon were a handful of gear brush DC motors which I envision might work as I attempt to create a crude micro-bit screwdriver and a dual-threaded tank platform which clearly will make for a super cool robotic implement. These, however, are projects for some other day. Do want to thank you for tuning to my YouTube channel and checking with me this quick introduction to the PAC5285 device. See you on the next one!